Hi everyone, and welcome back to Taste the Code. In the past few weeks, I've been working on a project that is turning out to have one consistent problem. The project in mind is a pellet burner, so I'm not there yet, but I've been taking the problem step by step, where I first took all of the components and I'm making them work one by one. So I already released videos about talking to an LCD, working with a real-time clock, and also interfacing a rotary encoder. And you can find all of them on my channel. But the problem that I'm facing constantly with the project is that I'm kind of running out of pins. At the beginning, I was using one of these Node MCU boards, but once I started connecting more sensors and devices to it, then it was obvious that I won't have enough to complete the project. So I then moved to the Arduino Nano, and this is where I'm at now. As you can see, I have the rotary encoder, the LCD, and the real-time clock, all of them working together. But one of the problems that I have with the Node MCU is that it doesn't have enough interrupt pins for what I need. And specifically, I need those for controlling the AC fan that I have on the pellet burner through these dimmer modules that you also saw in previous videos. So in the quest of finding a better replacement for the Arduino Nano, I've come across this microcontroller, and this one is the STM32F103 so-called bluepill microcontroller, which is relatively similar to the Arduino Nano, but it offers a lot more, and in this video we'll see what that is and how we can interact with the microcontroller. The good thing is that the microcontroller is compatible with the Arduino IDE, so theoretically we should be able to reuse any code that we have for the Nano. It should be easily transferable to be used on the bluepill microcontroller. At first glance, both of the microcontrollers are really similar, but we have a few more pins available on the bluepill. In terms of specs, it beats the Nano in basically any category. So it has more flash memory, it has more I/O pins, it has more PWM pins, it has more timers, it has better ADC with higher precision, it has more external interrupts, and this is one of the features that that I really need right now. It has more SPI connection, more UARTs. It has an additional I2C lines, and it also features a CAN bus. In my case, I won't be using that, but it's good to know that it has and can be used with some automotive projects. And here on the example, I basically have just a running blink example. Let me turn on that. And here you can see this green LED turning on and off. So as you might have already noticed, this board does come with a USB, but at the moment I have it connected through a USB to serial adapter. And that is because out of the factory, when this board arrives, it doesn't have any bootloader installed that can communicate with the chip through the USB from the Arduino IDE. So we need to basically use one of these FTDI adapters and connect the board to serial. Here I have VCC connected to 5-volt input on the microcontroller, and you need to make sure that you have the FTDI adapter set on 5-volt, or if you have it set to 3.3 volts, then you will need to use the 3.3 volt input. I have ground connected to ground, and then I have RX connected to A9 on the board and TX connected to A10 on the board. Now in the Arduino IDE, in order to be able to program this board, we need to go to the board manager URLs and add additional URL for the sources of the board. You'll find that URL down in the video description. And once we add that to the Arduino, we need to go to the boards manager, and that will update the list of the available boards. And here we search for the STM32, and we get two packages, but we need to install the second one because that's the one that we have the chip on the bluepill, which is the STM32F103C8. So we installed the second package, and depending on the computer speed and your internet connection, that might take a while. So wait until that process finishes. Once it's done, we can go to the boards and we'll see a new section for the STM32F1 boards. And from there, we can select the generic STM32F103C series microcontroller. Next, what we need to select here is the correct variant. So make sure that you have the variant with the right amount of RAM. And as the upload method, we're gonna select serial because that's what we currently use on the breadboard. If we now try to open this up and upload it, we'll see that we are basically not able to do so. In my case, the purpose for that is that I'm missing some drivers for the FTDI board, and that might be the case for you as well. If that happens, then find out the right version of the FTDI that you are currently using. In my case is FT232RL, and I'll leave the links to the drivers for that FTDI in the video description. So go ahead and download those and install them based on the instructions that you're gonna find on the page. In order to test out the microcontroller and make sure that it works, I first opened up the Blink example that's provided by the STM32 board that we just installed. And I'll modify that sketch. Instead of using the PB1 input pin on the microcontroller, I'll change it to use the onboard LED, which in my case it's connected to PC13, and you can see that on the board. It's usually marked, so that's how you basically know which variant of the board that you have. And once we change that, we need to install, as I said before, we need to install and set up the drivers for the FTDI breakout board. And in my case, that required me to uninstall the drivers that I already have for the board on the computer. And then I followed the procedure as explained in the documentation for the FTDI, and I installed the board drivers and also the USB port drivers, and that enabled the port in the Arduino IDE, so I could select the FTDI as a COM port and then program the microcontroller. Let's now repeat the procedure, and for that we need to turn off the power to the microcontroller and then utilize one of these pins that we have here, one of these jumpers, and they are marked as boot 0 and boot 1. Boot 0 is a special pin here that we need to connect in the second position, and that to the 1, and that enables the microcontroller to be programmed. If we now power on the microcontroller, we'll see that the code no longer runs. So you can see that there is no blinking LED anymore, and that erases the program that's currently in the microcontroller, and it's now in a state where it can be programmed. So now through the Arduino IDE, we can go in and upload the code once again. Okay, I've hit upload and it's now compiling the sketch. We should see some communication going on once it starts sending the data. There it goes, and it's now uploaded, and we can see that the LED is blinking once again. But now we have a critical step that we need to complete before we cut the power to the board, and that is that we need to return this jumper back to the 0 position if we want to keep the program that we have on the microcontroller for the next restart. If I now go and reset this board, it will again enter it in a state where it's ready for programming and it won't hold the code. So now I need to remove this jumper and return it back to the 0 position while the power is still connected. And if I now reset the board, you'll see that it continues running the blink program. While if I reset it while it was connected to pin 1, it will erase the program and enter programming mode once again. Now, although this setup works and it's usable and it gives us a microcontroller that we can use as it is, it really is a hassle to use the serial USB to serial breakout each time that we want to program because of the mess of the extra cable that it creates. So next step is to see how we can utilize the onboard USB and program the Arduino that way. The thing that we need to do is that we will need to change the bootloader that's on the microcontroller. So we replace it with a bootloader that knows how to communicate and program the chip via USB. One note before we go in and update the bootloader on the board is that you will lose some of the flash size on the microcontroller if you do so, but that in my case is not a problem because I never actually managed to run out of flash size on the Nano, and this microcontroller, as you saw earlier, has a lot more. So for me that will not be a problem, but if you have some really large project, then keep that in mind. Now let's go in and download all of the stuff that we're gonna need for updating the bootloader. And the first tool that we're gonna need is this FLASHER STM32 from ST. And this is a tool that will allow us to flash that bootloader to the microcontroller. So go in and download that. Next up, what we need to download is the drivers that we need for the microcontroller so the computer can know how to communicate with. And I'll download a zip from that as well. And the last thing that we need to do is to download the correct bootloader that we want to use on the board. I'll leave links down in the video description, but you will need, depending on the board, you will need the binary that corresponds with the pin that you have your LED connected to. In my case, as we saw earlier in the blink example, it is PC13. So I need that that file here. If, for example, the LED is connected to PB9, then you will need this version, and so on. So before running the flasher, we need to install the drivers, and we do that by starting the install driver bat script that starts this installing process, and we wait for it to finish. And now with the driver installed, we can press any key to close it, and then next step is to run the flasher, and we first need to install that. It is now installed, and we need to do one more step before we can launch the flasher and install the bootloader, and that is to switch the board to the programming mode as we did with the jumper. So we move the boot 0 jumper to position 1, and then we need to reset the board. So I now press the reset board, and we can see that the LED no longer flashes, so we know that we are now in programming mode, and I can go and start the flasher tool. And first we need to select the correct port. We select next, and we see that the target is readable. Click next to proceed. And so here's the target, and we see that we see here all of the memory pages that need to be unprotected, which is good in our case. We select next, and the option that we want is to download to device, and the file that we want to download to device is the one that we downloaded from the link previously, which is the bootloader for the board that we have. We open that and we press on next. So this is now transferring data to the microcontroller, and it's actually writing down the bootloader. Okay, the operation finished successfully. So we now have the STM32 Arduino bootloader on the microcontroller. We can now close this and we can go in and try this now from the Arduino. Okay, so now let's connect this board to USB, and I've modified the sketch that we have before. It still communicates with the PC13 LED, but I now modified it to only use half-a-second cycles. And here, instead of using serial, we need to change this to the STM32 Arduino bootloader. Everything else stays the same, and we now change the port to COM9, which is also presented as Maple Mini. And theoretically we should now upload, so it's now compiling. Let's see if this works. Okay, and we can see that we now have a faster blinking LED. Inside the Arduino logs, we can see that it basically resetted the device, and so we didn't have to change the boot mode when we loaded the sketch on the device. If we now turn off this and turn it on again, we'll see that after that boot sequence, it starts running the sketch that it was presented there on the microcontroller. And with that, we now have a running bluepill that can be directly programmed through USB. And hopefully next up, I can go in and replace the Arduino Nano on my pellet burner, but that will be in maybe the next video, or we'll continue using this microcontroller for the project. That was all for today. I hope that you managed to learn something, and if you do, then please like, share, and subscribe. It helps a lot, and I'll see you all in the next one. Cheers.